1. All right, so this is on section 4.1, which is really just the transformations of graphs. So before we get started, I really want everyone to know the parent functions, right? We need to know a couple of them. So the parent functions are just the graphs that are the basics, right? So you got the constant function, right? The constant function is just a line that's what? Straight across. Y'all notice how it's just straight across here, right? That meant f of x equals to some number, right? Or in this case, that would have been like y equals to, I don't know, 3, right? Okay, the next parent function that we need to know, or that you do know technically, is a linear function, right? Obviously, it's a line that's either what? Increasing or decreasing. That's just f of x equals to x, right? But the new one that you did not know, or you need to know now, is this absolute value one, right? It looks like a what? Looks like a V, right? Now, the key indication of what you do need to know is you see right here, this point, where does it drop down at? 0, 0. So that key point is what we need to know when we get to starting to transition and shifting our graphs. It's starting at our basic graph of what? 0, 0, looking like a what? A V. Make sense? All right, so now the next one that we need to know is, we have already done it as well, a parabola. Oh, I'm sorry, a quadratic, right? So what is another key point that you can look at? Oh, it's at what? 0, 0 again, right? But as long as it makes this nice, perfectly U-shaped curve, right? Then we consider that to be a quadratic. And quadratics are everything that are what? X squared, right? We agree on that? All right. So again, we need to know that basic function. F of x equals to x squared, or y equals to x squared, is something that is quadratic, right? Then my next one is f of x equals to x cubed, right? That makes a nice little what? Squiggly line, right? That's what I say, right? But notice, where does it pass through at? 0, 0, right? Notice all of these, most of these are passing through what? 0, 0. So I use these as our key points again to talk about where it's going to what? Shift. Okay? Shift at 0, 0. We're starting our shift at 0, 0. All right? So then my next one that we need to know is the square root. It looks like a hook. A hook to the what? To the right, right? Everything you own in the box to the right, right? So, where's my key point? Go figure again, it's at what? 0, 0. Okay? But the basic function or equation of that is just the square root of x. Okay? So, now, sorry, I got to zoom out. I got to zoom out. So, the next one is a cube root, right? A cube root is technically that squiggly line on its what? On its side, right? Okay. So again, the basic graph of that looks just like that. What key point does it go through? 0, 0. You're going to get tired of the 0, 0, but you know that 0, 0 is a key point, right? It's important. All right. Now, this is all, well, we got one more before I scroll down. We need one more second? Okay, we're going to do one more second. It looks like a cubic on the side. It is a cubic on the side. It is. That it is. That it is. Okay. Square root is only half, right? Because think about a square root. Can you have negative numbers in a square root? It makes it what? Imaginary, right? So technically, whatever numbers we plug in, it should still be a real number. So square root of 1, square root of 0 is what? 0. Square root of 1 is what? 1. You see what I'm saying? But the square root of negative 1, that's imaginary. We can't have that. Does that make sense? So we would have to have a little bit more information in our function in order for it to be on the other side of 0. Okay? All right. Now the last one that we need to know. This greatest integer? No, take that off. No, then that's out of the picture. We don't need to know the greatest integer. Yeah, that's too much right now, right? We will do in chapter 5, we'll do exponential and logarithmic. All right. Don't write it down right now, but you will see it later on. But you don't need to know this rational. Oh, that's crazy looking, right? But you do need to know the reciprocal, right? Reciprocal function is 1 over x, right? Yeah. Right. Notice one thing about that. Where does it not cross over? Zero. It don't cross over 0, 0. It flip. All right. So these are your basic functions. All right. Do we have any questions on our basic functions? I'm sure they're gonna get tricky. All right. So in section 4.1, and this should really say chapter 4.1 at the top. So in section 4.1, we look at the shifting of our graphs. So let's first talk about vertical shifts. It says vertical shifts says if k is a positive real number, right? The graph of g of x equals to f of x plus k is moved upward k units, right? And then it says the graph of g of x equals to f of x minus k can be attained by shifting the graph k units downward, right? Okay. So now, what do you mean by that? So remember those basic functions that I gave you, right? I gave you what? F of x equals to the absolute value of x, right? So if I say plus 2, that means I am going to shift our graph, right, up 2 units. That's what that means, all right? Because I added on a plus k. You remember those basic those basic functions, right? So we're moving it upward k units. Now, if I hypothetically said f of x equals to, I don't know, x, absolute value of x minus 5, right? That means we are shifting, right? What? 5 units, what? Units down. All right? Does it make sense? Okay? So let's do something really quickly. All right, so I gotta change it. We can't see them lines, right? Nope, I don't think we can see them lines. Can y'all see them lines? Can y'all see the lines now? Yeah, okay, great. All right, so let's take a look, right? So let's hypothetically say, right? Get a little space here. Let's hypothetically say right here. Oops, I didn't want blue, I want black. Bless you. All right, don't judge my lines. Don't judge them. Don't judge them now. Exactly. All right, so let's see. If we have our graph right here, right? The first one says graph the function x squared, right? So I'm just going to sketch x squared, right? So if I sketch x squared, what did I say the key point was? At what? 0, 0, right? And so I'm just going to do a rough sketch of that. Looks good? Okay. Now, the next one says graph what? G of x equals to x squared plus 2. That means we are going to move what? Up 2 units, right? So at that 0, 0, I'm just going to move it up 1, 2. And it's going to be at 0, 2. And I just still draw a problem. That's it. Yes, ma'am. When we shifting, it's always up and down the x. It'll never be on the y. Oh, we getting there. Yeah. Notice I said we're going to do the vertical shifts first. Okay. Uh-huh. Okay. Make sense? Easy enough? All right. She said don't get too excited. So let's just do another one for giggles, right? So let's just say g of x equals to x squared minus, which I want? Minus 3? All right. So minus 3. So that means from 0, 0, right? We go down what? 1, 2, 3 units. All right. And then, oopsies, Miss Parker. My hand got a little jacked up. All right. That's the graph. All right. Now, again, I'm just doing a rough sketch. Yes, ma'am.
Is it always going to be an x in front of the square? The square root?
When I don't have a square root, we got a square.
I'm talking about the exponent. Is it always going to be an 8 in front of the exponent? Or is it sometimes going to be maybe 5 squares subtract 3?
5 squares subtract 3. It's got to have an exponent. So it got to be on the graph. You got to, it's going to be one of those basic functions that I gave you.
Yeah. Okay.
Yes, sir. You said what? How do you know which points? 0, 0 is your starting point. So whatever direction is telling you right here is how you know how many is going to go past. -3 is going to go down. Plus. Say it again. Like the domains. The domain? Yeah, like what? We guesstimating right now. We just sketching them out. We just sketching them out. But the domain, what's your x values? Still looking at the graph is what all real numbers, right? Our range though would not go past what? If I'm looking at this one, our range would not go past -3. So it's just still using all the same thing everything that we did before is just still applying. All right, let's see. Let's do a horizontal shift really quickly, right? If h is a positive real number, the graph of g of x equals to f minus x minus h can be obtained exactly. It look a little different, right? So this is the way if I don't use the booked definition, right? If the h is inside of the function, right? Inside the function, right? And it's a minus a number, a minus h, right? Then you move it that minus h numbers to the right. You go in the opposite direction. So if it says minus, you go to the right. Oh yeah, but that's positive. Exactly. Minus, you go to the right. And if it is positive, you go to the left. And this is for your horizontal shifts. Okay, hold on. Let me process that real quick. Write it on down. Write it on down. All right, so let's do an example really quickly. All right. So let's say that I have a graph here. I'm going to take it here. Boom, boom, boom. It says graph what? X squared, right? X squared again is passing through what? 0, 0, right? All right, we're just doing a little sketch real quick, right? But now if we have x plus 2 squared, you see how this is inside of the function? Yes? No? Maybe so? F of x equals to x plus 2 squared. That means we are going to go what? 2 units to the left. Remember, opposite direction of its sign. So that'd be 1. That'd be what? 2. And you still just make a parabola. Okay? Well, that's a bad color too. All right? Make sense? Maybe, maybe not. All right? Now, occasionally, you may have a 2-for-1 special. What's a 2-for-1 special? You may have vertical and a horizontal. Mm-hmm. Okay? So, if I look at this, right? What we got? F of x, or no, it doesn't say f of x. It says what? G of x equals to x plus 2 squared plus 1. So this is indicating, this part right here is indicating that shift left, how many units? 2 units left, right? And then this one is indicating that you have up what? Up 1 unit, right? And it's starting from the basic graph of what? 0, 0, right? So again, 0, 0, we start right here, right? So if I go to the left, 1, 2, and then go up 1, there you have it. That's our answer. Oopsies, I guess I needed a different color. Yep. All right. Which goes back to, what did we learn about vertexes not too long ago? That this, again, what I just did on the board over here. The vertex was what? -2 what? to positive 1. That's where the minimum point should be. At that negative 2, positive 1. Oh.
Okay, so if it's inside of the parentheses, it's going to change. And the one that's on the outside is inside.
Correct. Inside the parentheses is going to change. Outside the parentheses will stay the same.
Okay.
Vertical will always stay the same. Horizontal will change. Okay? Horizontal will change. Now, if I am to give you a graph, right, you should be able to create or tell me what your equation would be. So, which way did this graph shift? To the right?
Down. And down. Oh, how many?
Ooh. There we go. Who said 6? Yeah, 6. Right? Why we said 6? Look at your increments. 2, 4, 6.
Yeah.
All right. So it went to the right 6, right? So if it went to the right 6, is that positive 6 or negative 6? It's negative 6, right? Ooh. Okay. And then it went down what? It went down 4, so that should be a what? A negative 4. So my function should look like g of x equals to what? Oh, what kind of basic graph is this? It's an absolute value. So the absolute value of x minus 6 minus 4.
Oh, okay. And we know it's the absolute value because
the base, you know it's the absolute value because the basic graph looks like a V.
Okay.
The only reason why the other one above was in parentheses is because it was what? Squared. But absolute value is in what? Actual what? Brackets, right?
And those numbers included. Get me.
All right. Hold on.
Right, yeah, hold on, wait. Right.
Okay, hold on. So if we look at this next one, right, it says write the equation of the functions g of x that is transformed from the given function f of x whose graph is shown. What does this basic graph look like? Square root. So we already know that it's got to be a what? A square root, right? Square root of x. Now, let's talk about which way did it shift. It went to the right what? It went to the right 1, so that should be a what? A negative 1, right? And then it went up what? It went up 2, so that's a positive 2, right? So remember, anything to the left and the right, or correct, is what? Inside of the function. So this should be the square root of x minus 1. You see how that's inside of our function now, right? Plus what? Plus 2. The plus 2 does not go underneath the radical, right? Because the plus 2 is indicating our vertical shift going what? Up and down. Okay?
Oh, that's called a radical thing to make it a square root.
Uh-huh.
Okay. I didn't know that.
All right. Y'all ready? All right. Now, before I do... the 2 is not in the bracket. It is not in the bracket. I mean, not the bracket.
No,
It's the radical. In the bracket. All right. All right. We're going to skip this question and then we're going to come back. Okay. All right. Because it's got one more thing I need to talk about. All right. So this last piece that we need to talk about is the stretching and compressing of the graph, right? So if we are talking about vertically stretching, right? So if I had a scrunchie, right? I ain't got no scrunchie. I ain't got nothing on me. All right. So if I was to take this underneath, it almost made it. If I was to take her scrunchie, right? And I was supposed to vertically stretch. You see how I made it what? Longer, right? Elongate, right? So when you are vertically stretching, it's just making your parabola more skinny. You know, when you stretch yourself out, Ooh, I look skinny, right? But when you compress something, right? When y'all ladies put them little compression things, all the fat rolls somewhere else, right? There you go. What happens? It gets what?
Wow.
It gets wider, right? So when we say vertically vertically stretch, we're going to elongate. When we say vertically compress, it does not mean that it's going to get smaller. It just means it's going to make it wider. All right. Now, the difference that you need to know is when you are stretching, right? When you vertically stretch, that means that your A is going to be greater than 1. So that's for a vertically stretch. All right. A vertically stretch means your A is going to be greater than 1. All right. For your vertically compress, right? That means your A is going to be between 0 and 1. Okay? So you have a vertically stretch, which means the number in front of your function is going to be greater than 1. When you are vertically compressing, that means the number in front of your function is going to be between 0 and 1. All right? Wait.
Yeah.
Yes.
I'm gonna write it down.
So when I have y equals to 3x squared, right? The 3 is indicating that it's going to be a vertically what? Stretch. Because the number in front of my function is greater than what? 1. When I have y equals to what? 1/3 x squared, right? That means the number is between what? 0 and 1. And that is going to be a vertically what? Compression. All right. Now, some people are still like, I still don't kind of visually see what you talking about. So let me pull it up, shall I? Boom. All right. So what's our basic graph? X what? X squared, right? We all agree it looks like that. Yes? Okay. If I did 3, not V, but X, 3x squared, right? You see how it's more narrow than my original graph? Mm-hmm. All right. And then if I did 1/3 x squared, you see how it's more what? Wider than my original graph. Do we see the differences between them now? Yeah? What's wrong, Ivory? You had the blank stare. Uh-oh.
I'm just writing right now.
You just writing.
Yeah.
I don't understand. That's the like between the numbers. If it's in between 0 and 1, then it's gonna be
Mm-hmm. Yeah, exactly. Okay. All right. We see.
Okay. Like what type of questions we'll get? Like, if you gonna ask us what the graph will look like, but if the graph smaller than the original graph, like.
So the questions would come from. Give me one more second.
Okay.
Give me one more second, and then we're gonna put it all together.
Got you.
All right. So let's see. Let's go back really quickly. So we see the vertically stretch and compress, right? So let's look at the last thing, and then we'll do a couple of examples, shall we? All right. So it says the graph of y equals to negative f of x can be obtained by reflecting the graph across the x-axis. So meaning if I have a negative on the outside of my function, right, I can now reflect it across the x-axis. Negative on the who? Outside. So for example, if I had f of x equals to the negative square root of x, do you see what I'm saying? The negative is on the outside of the function. Okay? That means I would reflect it across the who? X-axis. Now, I know you're like, I still don't see what you're talking about, so let's blur these out, right? What I said? SQRT, right? The square root. Oh, you don't want to do square root? Square root of x, right? So the square root of x looks like this, right? We all agree. Remember back at the 0, 0? Yeah. All right. So let's say we had, what was it? SQR.
Then
Parentheses x, right? But I said I wanted the negative on the what? Outside. You see how now it makes the graph reflected across the whoop? The x-axis. Because remember, this is your what? That is your x-axis, right? Y'all agree? Y'all remember? Yes? No? That is your x-axis, right? Uh-huh. Okay. But the next one, without me going back to the page, if you have a negative on the inside of the function, you reflect across the y-axis. So let's see. Square root. Well, is it gonna pop up? SQR. What was it? Parentheses x. I forgot the T. All right. Up. But I need to go inside. Put a negative on the inside. Boom. You see how it looks? This green one now. It's across the what? It's across the y-axis. Okay? Make sense? So negative on the inside of the function, we reflect across the y-axis. Negative on the outside, right? We reflect across the x-axis. All right? Whew.
Right. Negative outside the function, right? Negative outside function equals.
If the graph is obtained of f of negative x, it is obtained by reflecting the f of x across the y-axis. Yeah, exactly. That's the reason.
That don't even make it sound like.
Which goes back to where I said if the negative is on the outside of your function, what? You reflect across the x-axis. If the negative is on the inside of your function, you reflect across the y-axis, right? Now, one key thing that I do want you to remember, there are some graphs that do not have a y reflection. You're like, what? So let's think about it, right? If I go back to those parent functions really quickly, right? If I go back to the parent functions, look at the graph for a absolute value. Is it not split down or what? A y-axis, right? So we can't reflect something that's already in the what? Across the what? The y-axis, right? So this would only have a what? A negative. So this could only be what? F of x equals to the negative absolute value of x, right? It can't have, right? It cannot have f of x equals to the absolute value of negative x, right? Does that make sense? And it should make mathematical sense because what happens when you take an absolute value of x anyway? It becomes what? Positive, right? So we cannot have a reflection across the y-axis for an absolute value. We cannot have it for, guess what? A what? A quadratic. Because they are already mirror images across the what? Y-axis. All right? So,
What about the cube?
Cube root? Yeah, you can do it. It's not a mirror image. So if I split this graph down the middle,
Okay, I see.
There's no mirror image on this other side right now. It's across the origin, maybe, but not across the y-axis. Okay. All right. So let's take a look. Let's take a look at. Is this what I need? Yep, that's what I need. All right. So, that looks bad. Can y'all see that? Yeah. I don't know. All right. We'll bring it back up. So y equals to 2 cube root I'm gonna just say it says x plus 2 plus 4. Wait, that looks bad on y'all part too. All right. Can I change it out of this color now?
Yeah.
Yeah. All right. Thanks. All right. So boom. So if we're looking at this, right? Which way am I? So the question asks, the graph of this can be obtained from the graph of the cube root of x by shifting horizontally blank units. So how much does it shift horizontally?
Oh, hold on. Horizontal is
Horizontally.
we got a positive.
2.
So we gotta go to the left though.
2 units to the what?
Left.
To the left.
Okay.
Now make sense?
I got my notes right here.
You got your notes right there, all right? 2 units to the left. All right. So now after we do 2 units to the left, it says then vertically stretching by a factor of how much did it stretch?
No,
Stretch?
2, 3. Wait, it's a lot of numbers outside. I don't know.
That's the cube root though.
Oh, okay. So just 2 cubes.
It's just 2 cube, right?
And that's what we stretched by, right?
Yep.
Yeah,
So it's just, and when not 2 cube, it's just 2, right?
Oh, okay.
All right.
So
And vertically shifting, how much did we vertically shift?
4.
4, right? And then he said up, so that would be in the upward direction. Make sense? Kind of, sort of, kind of.
Yeah.
All right. All right, let me pause for a second because I gotta pull up the sheet. Ooh, all right, we'll do these 2 examples on the video and then I'll be. So, can I zoom in? The woman is blind in the back. She is blind. Whole lot of seats in the front, but she blind. All right, so the graph of y equals to the square root of x is shifted 4 units to the left. Then the graph is shifted 9 units upward. What would my equation look like? So y equals square root of x, which said? Plus 4 underneath the radical. Plus 9 outside of the radical.
Okay.
That's right.
Okay.
Look at y'all.
Right.
Okay. The graph of y equals x squared is shifted 5 units to the left and 4 units downward.
Okay.
So y equals x parentheses x plus 5
We dropping our
squared.
You was trying to give us that hint, and we was still
minus 4.
okay.
Yeah? Something like that. Okay. Shall we do one more?
For practice, yeah.
For practice, yeah. Okay, great. It says the graph of y equals to the absolute value of x minus 4 plus 3 can be obtained from the graph of y equals to the absolute value of x by shifting horizontally blank units to the blank.
4 units to the right.
4 units to the right. That is correct. All right. Then it says, and shifting vertically 3 units in the upward direction. Yes?
Yes.
I don't know. I heard from the same 3 amigos.
I'm gonna say no.
No?
You're not adding no more right now, right?
I got one more type. Let me see.
For review?
For review, yes.
Okay.
For review. But before we get there, all right, this is just a hypothetical transformation, right? Oh, okay. Ooh, gotta write it out now.
Okay, let me see.
So let's see how much did you move. I like the way you move. I like the way you move. I like the way you move. I like the way.
I'm gonna write that too. So
Okay, so it moves to the
It moved to the right 5. 5 to the right.
Yeah.
5 to the right.
Yeah.
So 5 to the right is a negative or a positive? It's a negative, right? Down to the 5.
Oh, let me tell you your equation.
Tell me my equations.
Parentheses.
X
minus 5 squared. Minus 5.
Minus 5. Ooh, that girl is smart. She is kind. She is important. Yes?
Yes.
Okay. Ashe.
Okay.
All right, shall we try one more?
Ooh.
Okay, let's try one more. Ooh, there go that V again.
You said something about the V.
Yeah, what the V look like? I done told you up there at the top. It's just absolute value, but all it did is move over what? 3 units to the what?
To the right.
So f of x equals to the absolute value of x minus 3.
That's it.
That's it. Yeah, that's it. That's it. Yeah?
Okay, and then hold on. I forgot that little tip you had gave us about absolute. You had just said something about it don't work for something. Oh,
for the reflection, yeah.
Okay.
It's not gonna reflect across no y-axis. Exactly.
That's gonna be one of your trick questions.
You already know. You already know this. Okay. You already know. All right. Pick up what I put down now. All right. So let's see. Okay, here we go. Let's try 2 more. Maybe 2 more. 2 more. Let's do 2 more. All right. Ooh. Yes.
All right.
So it says y equals to negative 5 times x minus 4 squared plus 7 can be obtained from the graph y equals x squared by shifting horizontally blank units to the blank vertical. So how much are we horizontally shifting?
We going 4.
4?
Yeah.
To the what?
Right.
To the right. Everything you own in a box to the right. And then vertically stretching.
Oh, 5. Negative 5.
Oh, don't put that negative on there. Just say 5.
Okay.
Because the negative indicates the what? The reflection. Aha.
Oh, and that's next. Reflecting over the y-axis.
Ooh, is it negative on the inside or the negative on the outside?
Wait, hold up.
If it's negative on the outside, it is a reflection across the x-axis. Yes.
Hold up.
And shifting vertically 7 units up. All right, we Cardi B up.
Because it's stuck, baby. Yeah.
Okay. You see how we're doing piece by piece? Now, a lot of your homework questions are just like this, though. They are literally just.
I was gonna say by the end of the week we're gonna be putting all of this together and trying to pull from quiz questions.
They are the exact same thing, but y'all just don't see. I don't know what it be.
Right, because
I be saying that, and I guarantee you, every single question that I give you, I guarantee you, I'll pull up one that's right mimic side by side, and then y'all go, oh.
That's why I use that view an example problem. I mean,
all right. View an example. Y'all gonna view an example on this? Okay. Now, the graph of y equals to x squared is shifted to the left 4 units. This graph is then vertically compressed by a factor of 1/6 and reflected across the x-axis. Finally, the graph is shifted 8 units downward.
This guy is multiple choice question.
Nope.
Okay, 1/6 x. Oh yeah,
Okay.
it is inside the parentheses now.
So somebody said who? It is negative.
Oh yeah, because we flipping it over.
Because it's reflected across the what?
Outside of the function.
So negative 1/6. Then they said a parentheses what? X plus 4
Yeah, so we went
to the 4 because we went to the left. Minus 8. That's it.
Yeah. Okay, I see. Yeah, you can see something.
Okay. Yes. No? All right, the people who've been really quiet, they gonna answer. That means no Ivory, no Lupe, no Cameron, no Kyrie. Huh? Go a little bit more up. Oh, you want to write it down again? Let's see. Who else I'm not gonna hurt? No Lovely. Did I call everybody? That not saying something 20 times? Okay. Everybody else, somebody gotta answer my next question. The graph of x squared is shifted 3 units to the left, and then this graph is vertically stretched by a factor of 6 and reflected across the x-axis. No, you were talking already.
No,
You did? You sure? Oh, okay. Go ahead.
so it's gonna be y equals -6
Uh-huh.
parentheses x subtract 3.
Mhm.
No, yeah, subtract 3.
It's to the left.
So plus 3
Mm-hmm.
squared
Square.
subtract 8.
Subtract 8. Y'all got questions for? Y'all believe in them?
Yeah.
Yes, ma'am. Because it says it's stretched by a factor of 6. So I'm gonna treat y'all like my statistics class, right? I'll be looking for the numbers and trying to just plug them in. Just go ahead and read the whole thing.
What if the 6 is positive?
Huh?
Is there any answer to be positive?
Positive 6?
Yeah.
It could be positive, but that's if it was. It wouldn't be a positive 6 though. It would just let me say this. If it was a positive 6, it would be vertically stretched by a factor of 6, but there would be no reflection. Does it make sense? The negative is only because of the reflection. All right?
Gotcha. Oh, because they pretty much letting us know it's negative by saying it's
Reflected.
reflected.
Mm-hmm.
Okay.
All right?
Now they said it was. Oh, this would be inside. Oh, they said if it flipped over the y-axis.